Hello pre-calculus students. This video is about parent function and their domain and range. This lecture contains 8 parent functions, which are linear, quadratic, square root, cubic, cube root, exponential, reciprocal, and logarithmic. First one is linear function, with its parent function is y equals x, and its domain and range are both all real numbers. Next one we have quadratic function. Its parent function is y equals x squared. Its domain is all real number, however its range is y is greater than or equal to 0. So y is y equals x squared, always above 0. If we square the real number, the result is always positive or 0. For example, if we plug in negative number, such as negative 2, then negative 2 squared is positive 4, not negative 4. That's why y equals x squared is always above 0. Next one is square root function, and its parent function is y equals square root of x. Its domain and range are both greater than or equal to 0. First, we're going to look for its domain. If we plug in a negative number for x, for example, negative 1, negative 4, or negative 9, the output or the y value doesn't exist in real number. If we look at the table here, if we plug in positive number such as 1, 4, the result is going to be a real number. But if we plug in a negative number such as negative 1 or negative 4, the result is undefined. Now we're going to look for its range. In general, square root of a squared can be both positive and negative a. For example, square root of 4 can be both positive 2 and negative 2. However, the function will fail the vertical line test and will have 2 outputs from one input. If we look at this image, which allowed both positive a and negative a for output, then the graph will have 2 outputs for a single input. For example, square root of 4 can be both positive 2 and negative 2, and this is not a function anymore. Now we have cubic function, and its parent function is y equals x cubed. Its domain and range are both all real numbers. So why do we have all real numbers for a range? Unlike x squared, x cubed can have negative value. If we plug in negative value, for example, negative 2 for x squared, then it's gonna be positive 4, not negative 4. But if we plug in negative 2 for x cubed, then it's gonna be negative 8. Now we have cube root, and its parent function is y equals cube root of x. Its domain and range are both all real numbers. Why do we have range? Why do we have all real number for a domain? Unlike square root function, if we plug in a negative number for x, then cube root of x will be a negative number. For example, if we plug in negative 8 for x, then cube root of negative 8, it's gonna be negative 2. Here's a table that compares square root of x and cube root of x. If we plug in negative number, then square root of x is undefined. However, cube root of x is a negative number, which means they are in real number. Now we have exponential function. Its parent function is y equals b to the power of x. Actually, we have two versions of exponential function. One is when b is greater than 1, and the other one is when b is between 0 and 1. And both of them has domain of all real number and range of y is larger than 0. If we compare two graphs, we can see that the left one increases as x value increases, but the right one decreases as x value increases. If you look at the table here, when x value increases, 2 to the power of x increases, but 1 over 2 to the power of x decreases. Next one is reciprocal function. Its parent function is y equals 1 over x. Both domain and range are all real number except 0. So why do we have exception at 0 for both domain and range? For domain, denominator of a fraction cannot be 0. For example, if we plug in 0 for x, then it's gonna be 1 over 0, and that does not exist. For range, numerator is 1, and there's no such x value that divides 1 and yields 0. Here's a table about x and its reciprocal function. As you can see, if we plug in 0 for x, then reciprocal function or 1 over x is undefined. And also values are going closer to 0 as denominator or x goes farther from 0. Here you can see that y value is going closer to 0 as x value increases, and for negative side, the y value goes closer to 0 as x value goes farther from 0. The last one is logarithmic function. Its parent function is y equals log x. Its domain is x is greater than 0, and its range is all real number. Why do we have x is greater than 0 for domain? Remember that log form, log base b of a equals c, can be written as exponential form like this. B to the power of c is a. If we use the same trick for our logarithmic function, then base 10 goes here, and y goes to exponent, and x becomes its result. So 10 to the power of y is equal to x, and y's power of 10 must be positive. If you look at the table here, when x is negative value, such as negative 2 or negative 1, or even 0, log of x is undefined. And if x is positive number, then the y value or log of x exists in real number. Thank you.